Hey guys, it's Mr. Ray here, back for the last section of the course. So we just finished off trigonometry. It's a very important topic in math. So hopefully you're able to take something away from that about how to find unknown sides and angles and triangles. Learned a lot of good tools. The trig ratios, sine, cos, and tan, when you have a right triangle. Along with the stuff you knew before, that the Pythagorean theorem and that angles add up to 180 inside a triangle. And then we ended the last two lessons of the unit were two brand new things. Also, when you're working with triangles that don't have a right angle, we had two tools, one called the sine law, one called the cosine law. So hopefully you're able to, like I said, remember some of the stuff. It's very important in the grade 11 and 12 math, but it's a pretty important topic in math. Okay, so we're going to end the course with talking about something called linear systems. Okay, now you notice we're actually skipping a lesson, so I just wanted to do a quick little summary of what is a linear system. Okay. So if you look at the two words, system, linear, I mean, you've seen that a ton in grade 9 and a little bit in grade 10 again, but linear is basically a line. If you were to graph a linear relationship, it would be a line, and a system, it means basically more than one. So if you have a system, it's got several things that kind of interchange and interact with each other. So what we're really talking about here is looking at, so overall a linear system is looking at more than one line at the same time. More than one line at the same time. So, I mean, you could have 2, 3, 4, all sorts of numbers. So let me finish this before I forget. Okay, now in grade 10, instead of just saying more than one line, we just kind of change that to 2 lines. So we'll always be looking at 2 lines at the same time. So if you were to graph something like 2 lines, you know what a line looks like, so maybe that's one line and here's another line. Okay, so in terms of anything interesting that you don't see when you just have one line, the only real new thing is where do the lines meet. Okay, so the lines usually will meet at one place, and we call that point the point of intersection. Now that's a lot of writing there, so being lazy, we just shorten it to POI. So if somebody asks for the point of intersection, you just say the POI is, and then you'll just give the points, the coordinates. So maybe this point of intersection was the point 3, 5. Both lines actually go through that point. That's where they intersect. So that point is actually on both lines. It's the only point where that's true. Okay. Now it is possible to have a linear system where the lines don't even meet. So if I just did a quick little graph down here, and when would they never meet? Well, if the 2 lines were parallel. Okay, but not a lot of real interesting things going on there. And the other situation that can happen, it's kind of I've always thought it was a bit of a cheat. Maybe the 2 lines happen to be the same line, and it just doesn't look that way in the equations. Well, what's the point of intersection here? You'd have infinite POIs, whereas this you have 0 POIs. Okay, but for the point of the rest of this course, we'll just be looking at situations where there's one point of intersection. Okay, but I just want you to be aware that you could have 2 lines that never meet, or the 2 lines that happen to be the same line. Okay, so you can see from the first way I represented this, one of the ways you could find the point of intersection would be to graph the 2 lines and then just look at the graph and go, oh, they meet there, and that's the point of intersection. That's actually the first lesson in this unit, but we're skipping that, and there's a good reason for that. Solving a linear system by graphing is the least efficient and least accurate way. It's time consuming, and sometimes you might have to do more than one attempt, and sometimes you're estimating where they meet, because maybe it's a fraction, like 5/16, and you're just guessing as to what the value is. Okay, so we're skipping ahead to the two other ways of solving. So the first lesson is called something called substitution. The next lesson will be a method called elimination, and you can use either method. Now there'll be some situations where substitution is a better choice, and other situations where elimination is a better choice. Sometimes they're both good choices. I'll talk about that when we look at some examples. So today we're learning about substitution. Okay, so this method is, we're trying to find where these two lines meet. And you might think, well, that's kind of a limited topic, finding where two lines meet. Like, how often would you have to do that? Well, there's an underlying application with this, and that's every time you have, maybe you have two different variables, and two equations with those two variables, and you want to find what value of x and y make this true, or what values of a and b make it true, and it actually has a lot of really important underlying applications. We're going to do one last example of today. We'll probably do another one in the next lesson, just to play around with it. And then the third lesson and last lesson of the course, we'll just be looking at applications. Okay, so there'll be 3 lessons. We'll do 2 lessons this week. No assignment this week, and then I'll do the third lesson like on the Monday, like a week from when this lesson was put online. And then I'll basically give you the assignment for the linear systems right away, probably the same time, and then you will just submit it by Friday. So hopefully that kind of winds down the course nicely. If some people haven't submitted some of the assignments yet, time is getting to the end of the course, so you're going to have to bear down and finish off. Okay, it's not just for the mark. I keep saying that. Okay, you're all guaranteed the mark you had as to when we were on break, but I'm more worried about going into grade 11 and being properly prepared. So let's finish this off strongly, and I think you'll find some of the questions kind of interesting once we learn the techniques in the first 2 lessons. Okay, so enough of my jabbering. Now, the very first thing we have here is like a set of steps. How do you solve a linear system by substitution? I'll just talk about the first 2, and then we'll come back to the others. Otherwise, it'll just be in through one ear and out the other, because it's too much information at this point. So what we have to do is pick one of the equations, and there's always 2 equations because it's 2 lines. Rearrange one of the equations for one variable. Okay, so basically what that means is isolate one of the variables in one of the equations. Okay, and then we'll come back to this after. Okay, so let's go right to the first example here. It says the lines y equals negative x plus 8 and x minus y equals 4 intersect at right angles. Now, this is totally unimportant here. The fact that they intersect at a right angle is not even going to be used here. So it didn't have to be part of that. They actually do intersect at a right angle, but that's not going to be actually used. Okay, find the coordinates of the point of intersection. So now, you notice these 2 equations, this first equation, and what I'm going to do is I'm going to write them. Usually I'd write them down here, but I want to save some space for the solution. I'm going to rewrite them so that one is above the other, and I've got like a label, a number. That's the first equation, and here's the second equation, That's number 2. Now the reason why we label them, now that we're working with 2 equations, you don't want to have to keep saying over and over, I don't want to have to name this x minus y equals 4 every time I'm talking about it. I just say equation 2, equation 1, and so on. Okay. Now, first thing we have to do is we're going to pick a variable. Now you notice there's 2 variables, x and y in both equation. So our first job is to pick a variable. It could be x or y. People sometimes think it has to be y because you're used to, y equals mx plus b, but it could be x, could be y, it doesn't matter. Okay. Now you can see these 2 equations here. This equation is already isolated, has already y isolated. So for us, the work, that first step is already done. That first equation is already rearranged for y in terms of x. So we're done. So we can go to the second step. Hopefully you can see that at the top. Substitute the expression from step 1. So now that we've got it isolated, since it already was isolated, we're going to plug in the value of y in the other equation with whatever we have here. So I'll show you what I mean when we do it down here. So, and it's important to communicate what you're doing because it can get pretty ugly if you just put a bunch of equations and arrows and stuff. I want to see some words like substitute because that's what we're doing here. And I'm going to take equation 1, which is isolated. I'm going to substitute equation 1 into equation 2. So substitute 1 into 2. So that means I'm starting with 2. So I'll just rewrite 2. X minus y equals 4. And I'll put a 2 just to remind myself that's equation 2. But now what I'm going to do, you notice equation 1, I'm going to replace the y with whatever I have here. So the best way to do this, and you might think it's overkill for this one, but wherever I see the y, I'm going to put some empty brackets, leave room for a couple of terms. So I'm basically, there's equation 2 again, but I've kind of replaced y with a set of empty brackets. And then what we do is we actually substitute the value of y from equation 1, which is that goes right inside the brackets. So it goes negative x plus y. And you notice now equation 2 is changed from having 2 variables, x and y, to just having one variable, which is x. So that means this is now a linear, equation that we can solve for x. So we have to, now the brackets are important here, because if you didn't put the brackets in here, you're going to get a wrong answer, because we're actually subtracting negative x and positive 8. So if I was to rewrite that, subtract negative x means add x, and then subtract 8 equals 4. 2x minus 8 equals 4. Okay, and so now we're going to add 8 to both sides. So this is your basic kind of equation solving skills. So add 8 to both sides. I get 2x equals 12. And then divide both sides by 2. And we get x equals 6. And that's our first big moment in this. We've actually found the value of x for the point of intersection. So these two lines or equations, they're going to meet at the x coordinate 6. So the only thing we're missing at this point is, well, what's the y coordinate? So this is the easy part. So we take this first coordinate that we got and we substitute again. We put this back into, and now it's kind of our choice. We can plug it into either one of these original equations here, whichever one looks easier to work with. And the fact that we're trying to find y should tell you that equation 1 would be the best thing, because it's going to tell us what y is right off the bat, whereas this one we have to do a little rearranging to get y. Okay, so substitute x equals 6 into, and again I use my label 1 for equation 1. So I'm going to start writing it. So y equals negative, and I'm going to put the x in brackets, and then plus 8. So this is basically equation 1, but I've put empty brackets where the x was, and now I just plug in the value of x that I'm substituting. Okay, and So that's y equals negative 6 plus 8. That's equal to 2. Well, that's our second coordinate. So that gives us both the coordinates. Now we can actually say, therefore, the POI is, the point of intersection is, and I'm going to put it in point form, in coordinate, because this is a point. You always have to put the x first, and then the y with a comma between, brackets around it, and there's our answer. Excuse me. So if we go back to the steps, kind of, ignored the rest of the steps. Substitute the expression from step 1 into the other equation. That's what we did here. And then substitute back into one of the original equations to find it. So that was this step here. Substitute that back in. And then this last step, this is not so much to find the answer, but to check the answer. Okay. Now, the cool thing about solving linear systems is you can always check your answer. You always can basically leave the question knowing, this worked or it didn't work. I got the right answer or I didn't. Okay. So what a check is, I'd always draw a line underneath because we've basically done the answer. That's our answer. And underneath I'm going to say check. And then the answer we got, 6, 2, to see if that actually works. Now the way we're checking it, and this is important, we actually are going to plug this point back into each of these two equations separately and to see if it works. And if it works, if I plug x equals 6 and y equals 2 into this equation and the left side equals right side, that means that that point is on that line. And if I do it for both lines and it works, that means this point is on both lines, which has to mean that's the point of intersection, because the only way that this point could be on both lines is if it's where they meet, obviously. Okay, so the way we do that, so I'm gonna do equation 1 here and equation 2 here. So y equals negative x plus 8, and then over here x minus y equals 4. Okay, so now I'm just going to plug in, that's the x value, that's the y, so I'm just replacing y with 2 and x with 6, so it's negative x, so it's negative 6. And I'm not trying to solve anything here, I just want to calculate the left side, right side. So the left side is still 2, and then negative 6 plus 8, or 8 minus 6, that's also 2, and that works. So that actually tells us that that point that we got in our answer is on the first line. Now, a lot of students will think, oh, great, we're done. No, you have to actually check both lines because you haven't proved yet that this is the point of intersection. All we've done so far is prove that this point is on this line, but it might not be on this line. So we have to do both. So now I'm going to plug in x equals 6, y equals 2 here. And you can see how quick the math is. Very easy. 6 minus 2 on this side is 4. And of course 4 does equal 4. I put my 2 check marks. This point is on both of these two lines. It must be right. Okay, so that's what it means by checking. On an assignment, you only have to do this if I ask you to check your answer. Okay, now, does that mean you should not do that on other questions? No, I would always do this. You can see how quick it can be. You don't even have to really write it down. You can just plug it in your head and see if it works. But it's so much nicer walking away from a question knowing that you definitely got the right answer. Okay, so take advantage of that. Don't just hope that it's right. You can know if it's right by checking. Okay, so let's try a couple more here. We're going to do 2 more, and then we're going to do a word problem and use this technique. Okay, find the solution to the linear system, and again we've got two equations, both have x's and y's. So I'm going to actually label them here, so I know which one I'm talking about. Now, remember the first step is you want to isolate one of the two variables, x or y, in one of these equations. So it could be either equation, it could be either variable. So you really have 4 options. I could isolate x in this equation, could isolate y in this equation, and x or y in this equation. I got 4 choices. So the best way to know which one to isolate is you look, in this case, none of them actually have x equals or y equals, right? So we have to actually rearrange. So the best choice for rearranging, you look for the coefficient of the x's and y's. So for example, the coefficient of this x is 1, coefficient of that y is 1. We have a 3 for this x and a -1 for this y. So the best choice is always 1. So either choosing to isolate for x or y in the first equation is equally a good choice. The other two choices would be not quite as good. So here's where people will do things different ways. And we should all, if we do it right, it should end up in the same. So we're going to take equation 1, and I'm going to rearrange it. So x plus y equals 5. Okay, now I'm going to decide I want to rearrange for x. So if I want to get x by itself, what do I have to do to both sides? I have to subtract y. So when I do that, I get x equals 5 minus y. Now, that's the first step. So I'm actually going to give this equation its own label, its own number, just so I can refer to it. Now, these two equations, they look different, but they're actually the same line. And that's what rearranging does. It doesn't change the actual line or the points on the line, but it just changes the way the equation looks. Okay? So these equation 1 and equation 3 represent the same line. Okay? So now what I'm going to do, I'm going to substitute. Now we always use what we just isolated, equation 3 into. Now we got to pick the equation to substitute into. Now we don't really have a choice. I can't substitute this back into 1 because that would be putting an equation back in itself. That makes no sense, and you'll get 0 equals 0, which gives you nothing. So it has to be the equation we didn't use, which is 2. Okay, so just like we did last time, I'm gonna write out equation 2, and then I'm going, since I'm isolating for x, I'm going to replace the x here with a set of empty brackets. Okay, so 3 empty brackets minus y equals 7. What goes inside? Well, what's the value of x? Well, according to this equation, it's 5 minus y. So put that in, and then we expand it. So 3 times 5 is 15, minus 3y minus y equals 7. So I'm going to subtract the 15 from both sides, and I'm going to combine the y's. So I get negative 4y equals 7 minus 15 is negative 8. And then when I divide both of those by negative 4, kind of running out of room here, I'm going to get, those cancel, I get y equals 2. Okay, there's our first big accomplishment. We've actually got the y coordinate of where these two lines meet. Okay, and the last part will be to take that value and plug it into one of the two equations. So substitute y equals 2 into, now it's really your choice. I guess we could do this, but I would kind of recommend that we use one of the original equations. Okay, so we're going to plug that into equation 1. There's really no advantage to either one. So x plus y equals 5. And then we're going to change the y to a 2. So that's x plus 2 equals 5. Subtract 2 from both sides, we get x equals 3. And that's our x coordinate of the point where these two lines meet. So you're not quite done when you get here. You've got all the information you need. Now you just have to wrap it up. So therefore the POI is, and we put it as a point, because point of intersection. So the x coordinate, this time we got x coordinate second. That doesn't mean we put it here. X always goes first. So 3, 2. That's where the lines meet. Now, remember what I was talking about. You don't have to do a big formal check here. I could just go back and say, okay, I think the answer is 3, 2. If I plug that into the first equation, 3 plus 2, yes, that works. 3 plus 2 does equal 5. If I plug it in here, 3 times 3 is 9. 9 minus 2 is 7. That works too. So without formally checking it on paper, I proved to myself that that is the right answer. Okay? All right. Now, you could ask this type of question. The first two questions we got, it says find the, well, actually, no. The first question said find the point of intersection. Second question actually asks find the solution. And this one says, where do these lines intersect? It's really just asking the same thing in 3 different ways. So where do the lines intersect? What's the POI? What's the solution to the linear system? The answer is always the point where they meet. Okay, so the POI. So you can always answer back by just saying, therefore the POI is. If you want to change the wording, that's fine, but I don't want you to get confused. These first 3 questions are all asking for the same thing. Okay, where do these lines intersect? Okay, so the first thing, I'm always going to put them kind of above each other with a label. Label 1, 4x plus y equals 9. Okay, now the first thing I look for, because I'm going to do this method substitution, do I have x equals or y equals for either equation? No, I don't. So now I have to rearrange. Now remember, rearranging, you've always got 4 options. Rearrange. Okay, I could isolate equation 1 for x, equation 1 for y, equation 2 for x, equation 2 for y. But again, best choice, look at the coefficients, and you're looking for positive 1. Coefficient there is positive 2, negative 1, positive 4, positive 1. So I think this is the best choice. Now that doesn't mean if you rearrange for something else it won't work. What you want to try to avoid is fractions. We haven't had to work with fractions yet, but if you tried to rearrange for this x in the second equation, you'd end up with some nasty fraction work. So try to avoid that. So I'm going to rearrange equation 2. So 4x plus y equals 9, and since I want to rearrange for the y, how do we get the y by itself? I'm going to subtract 4x. So y equals 9 minus 4x. Okay, now that's the new equation 3, which is the same line as equation 2. Okay, so now when I go to the next step, I'm going to substitute my isolated equation. So substitute equation 3 into, now be careful again, you don't really have a choice here. You can't put it back into 2 because these are the same. You have to put it back into 1. So I'm going to start off by rewriting equation 1 again. 2x minus y equals 4. And now I'm going to just put some empty brackets where the y is. 2x minus empty bracket equals 4. What's y equal? 9 minus 4x from the other equation. And now we're just going to, I'm going to subtract each of these first. So 2x minus 9 minus negative 4x is plus 4x equals 4. Now I'm going to do a couple things at the same time here. I'm going to combine the x's on this side, so that's 6x. And then I'm going to add 9 to both sides. So 4 plus 9 is 13. And divide by 6. And, you know, it's not always a perfect world. Sometimes it's a fraction. And that's what it is this time. This time y is actually equal to 13/6. And avoid the temptation. If you do 13 divided by 6 on your calculator, you're going to get like 2.166666 forever. You have to leave it as a fraction. You never round when you're doing most math, and includes linear systems as well. So we're going to keep it. That's 100% accurate. It's not rounded, it's exact. Okay, last step, substitute x equals 13/6, sorry, and we could plug it into either one of these. Not sure if there's a better choice, but I'm going to plug it into 1. Okay, so I'm going to start with equation 1, 2x. So I'm going to put empty brackets where the x was. 2x minus y equals 4. And the x was 13.6. Okay, so let's work with this. We can't avoid the fractions. So remember, 2 times a fraction is the same as 2 over 1 times a fraction. So that would be 26.6 minus y. And I'm going to save myself one step here. I know that I'm eventually going to have to combine these two numbers together. So they have to have a common denominator. So I'm going to do that right now. I'm going to change the 4, which is like 4 over 1, into something over 6. So multiply the top and bottom by 6. I get 24 over 6. Okay, so I can now subtract the 26.6 from both sides. And it's like 24 minus 26, which is negative 2 over 6. Okay, and now we have negative y. This isn't the answer. In order to get the right answer, I'm going to divide by negative 1 or multiply by negative 1. It's probably not the best way to show this. So first thing I can do is I can reduce the fraction. So I could say negative y equals negative 1/3, and then just multiply both sides by negative 1. So I get y equals 1/3. Of course, I'm running out of room here. Maybe I'll put the answer over here. Therefore, the point of intersection, short form, is, and again it has to be written as a point, look for the x value first, 13/16 and 1/3. Sorry, 13/6. Keep saying that. And you could check this. You could plug it into here. Obviously, it's going to be a little more complicated because they're fractions, but it will work. You could also plot these two lines on Desmos and see where they meet, and they'll be at that point. Okay. All right. Let's try something a little fun, more fun. Okay, so we're going to have our first word problem. So linear system word problems, like I said at the beginning, they have two unknown variables. They have, could be x and y, could be a and b, could be, f and g. It doesn't really matter. We want to find the values of those two things that we don't know right now. So in this question, it's kind of an interesting question because it doesn't give you any equations. And that's going to be true of just about every word problem. They don't give you equations, they give you sentences. And it's our job to create equations. Okay, so let's read the question. Stephanie has 5 more fish in her aquarium than Brett does. The two have a total of 31 fish. How many fish does Stephanie have? How many fish does Brett have? Okay, so it doesn't really seem like it's quite involves linear system, right? Because you're not really thinking about lines here. You're thinking about two unknowns, and the two unknowns here is the number of fish Stephanie has and the number of fish Brett has. So before I can make equations, I have to actually define what those variables are and what they represent. So this is where you do your two let statements. So let, and I'm going to pick a variable. Now we could be boring and just use x and y. Or you could be more interesting and say, let's use a variable that actually means something. So the number of fish Stephanie has and the number of fish Brett has. But we probably shouldn't use f because that would only work, we could only use it once. So let's use their names. So let s represent. Now don't say anything too vague like Stephanie's fish. It's not, because you have to say exactly what s represents. If I said let s represent Stephanie's fish, it might mean, how much they weigh, how wide they are, how long they are, how tall they are. Lots of different things about Stephanie's fish. We just want to know how many fish Stephanie has. So let s represent the number of fish Stephanie has. Okay, and now when you take the time to do that, it'll make it a lot more sense when you're making equations. If you're too vague and just said let s represent fish or Stephanie's fish, it doesn't really help you with the equations. Okay, now when you take the time of that first equation, the second let statement, the second let statement is super easy because the only thing changing is the new variable and maybe Brett here, right? So obviously we're going to pick b, little b, to represent the number of fish Brett has. So take advantage of the fact that only two things change here. Put these quotes, saves you a lot of energy. Okay, so now we actually have to make two equations, and if it's a linear system, it's always two equations from the information that's given here. So you notice there's two numbers given here. There's the five more fish, and they have a total of 31. So this one is actually easier to start with. So how can I make an equation with S and B and the number 31? Well, how do I get 31? I add Stephanie's fish with Brett's fish, the number they have. So that's basically S plus B equals 31. And there's the first equation. Okay, the second one's a little bit more difficult. Sometimes you play around with it. Stephanie has 5 more fish in her aquarium than Brett does. Okay, so how would I get the number of, if I knew how many fish Brett has, would I know how many fish Stephanie has? Yes, because Stephanie has 5 more than Brett. So I could say, if we took Brett's fish, the number of fish Brett has, and added 5, we would get the number of fish that Stephanie has. Okay, and you got to be careful with your 5s and your S's, especially for me. Make it obvious so you're not messing it up. Okay, there's the second equation, and that's all we need. So you notice when we go to the next step, where we want to isolate one of the variables, just like we did in the first 3 examples, you can see that this second equation already has S isolated, so we don't have to rearrange. We're going to go right to the substitution. So I'm going to say substitute equation 2 into equation 1. So I'll do this a little bit quicker now. So I'm going to plug it into equation 1. So I'm going to write S plus B equals 31. That's equation 1. And now I'm going to, wherever the S was, change that to B plus 5. So B plus 5 plus B equals 31. You notice now the equation, no more S's because we replaced S. So I can say 2B, add those two together. I'm going to take away 5 from both sides, 26. And now when I divide, I get B equals 13. And right away, you know how many fish Brett has. Brett has 13 fish. And you could probably figure out how many fish Stephanie has because word problems are more obvious. But I'll finish this off mathematically. Substitute our answer that we just got, B equals 13, into, I'm actually going to plug it into 2 because I'm going to switch the order here. S equals B plus 5, and we know B is 13. So S is 18. So we got the two values, B and S. We know that Stephanie has 18 fish and Brett has 13. So I'm not going to say they intersect at the point whatever because that makes no sense. The answer to this will be a statement, a word statement. Therefore, Brett has 13 fish and Stephanie has 18 fish. Okay, and checking here is actually a lot easier with word problems. I can actually read the information. The two have a total of 31 fish. Is that true? 13 plus 18, yep. And Stephanie has 5 more fish than Brett. 13 to 18, yes, that's true. So I don't even have to do a formal check. I can just make sure that these word statements are true with these values. Okay, and so make sure that you always answer with a word statement. Don't end with just the S equals B equals or whatever it is. So you can see the word problems, and we'll talk a lot more about this in lesson 3, 2 lessons from now. You always start off with your let statements for the 2 variables you're using, what they represent, and then you have to create the linear system, and then you solve the linear system, and then you interpret the linear system. So this is like word problems are like linear system sandwiches, okay? The top part of the sandwich, the let statements and the equations, and then the middle part is the math solution, and then the bottom piece of bread is the word answer, okay? So not too many homework questions here. I would like you to definitely practice this. So try some of the questions from there. And then on our next lesson, which I'll put out on Google Classroom on Wednesday, we're going to learn the second technique, which is called elimination. Okay? All right, guys, have a great day.